All right, class, in this video, we want to continue working on Pythagorean theorem, but we're going to focus on some application, and in particular, locating distance or determining distance on a coordinate plane. So I've given you an example here. We want to find the distance between point A, which is located at 3 in the x and 0 in the y, and point B, which is located at 7 on the x-axis and -5. That's the coordinate locations of A and B. And we want to use the coordinate plane. And so what I've attempted to do is break this down into several steps, 4 steps to be exact. The very first thing you want to do is graph the given points. Here are my given points, and I simply want to correctly locate them on the graph. So this is at 1, 2, 3. And that is an A, that's point A, 3 in the x, and I'm 0 on the y-axis, right there at 0. And point B is located at 7 on the x-axis and -5 on the y-axis. My next step is to create a right triangle using the given points. And so for that, I simply follow my vertical axis from point A straight down. And then I go to point B and I create a horizontal line following this x-axis. Well, it's not the x-axis, but this line parallel to the x-axis. And I'm looking for the point where they intersect. And they intersect right there. Now, I don't need this coordinate location necessarily, but when I go to step 3, it says determine the angle's base and height. And that is this. That's going to be the base. And this would be the height. We want to determine both of those. There's a couple of ways you can do that. If you draw it well, you can simply count. I start here and I go 1, 2, 3, 4, 5. So it's 5 units high. Starting from B, 1, 2, 3, 4. That's 4 units high. You could also look at it as my x-coordinate for A is 3. My x-coordinate for B is 7. What's the difference between the two? Well, and that difference is 4. Now don't get confused. That's going to be your x-axis, so that's this distance. That's 4. What's the difference between -5 and 0? Well, we have to deal with absolute value here. And so the distance between those two is going to be 5. What's our next step? Now that we have a triangle, we have a right triangle with a base of 4 and a height of 5. I simply want to apply Pythagorean's theorem and solve. So I'm going to take the two legs, I'm going to square them, add them together. We did that in a previous video. That's going to be 16 plus 25, and that equals 41. So 41 equals c squared. I've written the variable first here, so c squared equals 41. I need to solve for c, so I take the square root of c, but what I do to one side, I do to the other. So I get a value of c, which in this case, if this were c, that means this section here would be c. So c is equal to the line segment AB. Well, what is that equal to? The square root of 41. And that is the exact answer. But as I said in the previous video, and as we have been doing in class, we will approximate a decimal value to the nearest tenth. And approximately that is going to be 6.4. All right, let's try some examples. Let's try a practice problem, I should say. I'd encourage you to stop the video at this point and go ahead and try this one on your own. All right, now that hopefully you have attempted this one on your own, we will start working through our steps. I'm going to work to create a right triangle. So this would be point C. That's going to be C out there. And I am looking for what is the distance of line segment AB. Well, what's the distance? What's the base? All right, that's going to be 1, 2, 3, 4. All right, 4 is there. What is my height? Starting from B, 1, 2, 3, 4, 5, 6. Okay, so now I have the right triangle. I have the sides of the triangle. Now let's apply Pythagorean's theorem. A squared plus b squared equals c squared. So that will be 4 squared plus 6 squared equals c squared. 16 plus 36 equals c squared. And so that is 52 equals c squared. All right, now remember your golden rule of algebra. We have to take the square root of both sides because I'm not solving for c squared. I'm solving for c. So c is going to be equal to the square root of 52, or approximately 7.2. All right, hopefully that worked out. If not, back up and watch the previous part of the video and try it again. Let's look at one more practice problem on this video. It is a little bit more involved. You'll notice that I have two different lines. I have AB and BC. Now, I would encourage you to read the instructions here. What I'm asking for, pay close attention to the fact that each unit on this graph represents 0.5 miles. And I'm asking how much longer is line segment BC, this one, than AB. So if you haven't done so, pause the video and give this problem a try on your own. All right, so let's do our same process. Let's start at the top and let's create a couple of right triangles. So there's one right triangle, and that's going to be 1, 2, 3, 4, 5, 6 for the height, and 1, 2, 3, 4, 5, 6, 7, 8 for the base. And that is a 3, 4, 5 triangle. So I know that AB is going to be 10. Let's create another right triangle. And there's this one. Let's go from B, 1, 2, 3, 4, 5. So that's a 5. And let's go from this point that I just created here to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this overall base is going to be 12. Well, guess what? That is a 5, 12, 13 triangle. And so I know this, that, change colors, I know that BC is equal to 13. And I know that AB, the line segment AB, is equal to 10. Now, it's very tempting to do this, 3. And let's say miles, that BC is 3 miles longer than AB. But that would not be true because I know that each unit represents a half mile. So we would want to multiply this by 1/2 and get 1.5 miles longer. That BC is 1.5 miles longer. You could also instead do this, multiply each of these by 1/2, and I'm really just doing this arrow to separate it. That's going to be 6.5. That would be 5.0, but look at that. When you subtract, you still get 1.5 miles longer. All right, students, I hope this helps. Please let me know if you have any questions.